But here's the problem. We'd already been consulting with multiple electricians, running voltage drop calculations, and doing our homework, and we just aren't comfortable.
Stuff is everywhere.
Hey, remember when we said this is going to be a boondocking game changer?
Yeah, about that.
This video has been a long time coming, and if you saw our 12-volt AC installation video, you've probably been waiting patiently for this one. Hopefully, after watching, you'll see why, and hopefully you'll agree that it was worth the wait.
Before we dive in, let's clear something up. What's the big deal about 12-volt ACs anyways? Traditional air conditioners run off 110 volts, which means you'll have to have a generator, big inverter, or be hooked up to shore power. Most rooftop models push 13,500 to 15,000 BTUs, but they also draw huge amperage at startup. Great for campgrounds, but not exactly ideal if you're running off batteries or trying to go boondocking. A 12-volt AC, on the other hand, runs directly off your battery system. No inverter required, which means it's great for off-grid setup. They're typically quieter, more energy efficient, and don't hit your system with that massive startup amperage surge. Most of these units run from 10,000 to 13,500 BTU, with average power draws between 45 and 65 amps, depending on the settings. Some of them even come with built-in heaters for all season use. In case you haven't noticed, there's a lot of 12-volt AC brands out there, and if you look real close, they all pretty much look the same, with slight wiring kit variations, what they include, extra components for thicker roof installs. Some come with separators for the intake and outtake box, and of course, everyone slaps their own branding and their name on it.
Price-wise, they range anywhere from $800 to $2,000, which puts them in direct competition with your regular rooftop AC. But with the added promise of inverter-free off-grid cooling, the wiring kits usually come pre-packed with everything and advertised to be a pretty easy install, at least on paper. Here's the deal. We didn't think many people would care about the wiring when we did the install video. Why? The wiring depends on run length, battery location, voltage drop, and draw, and even what kind of cable your setup can physically accommodate. It's not a one-size-fits-all answer, and when we looked through other 12-volt AC install videos, some with 10, 20, 30 plus K views, no one was talking about it. No comments, no questions, no deep dives. So I figured most people just want to see how the AC was installed and how it worked. Right after the video install dropped, those wiring questions hit hard.
So, time for the game plan. The goal from the start was a clean looking professional install. No exposed wires, no wires on the roof, no janky shortcuts.
We plan to put a 1.5 inch hole through the roof, directly over a wall cavity, and use that to route our wiring inside the rig. From there, we'd run a 1.25 inch gray non-metallic conduit through the wall opening and turn it into a protective wire chase. That conduit would terminate into a weather-sealed 6x6 junction box mounted on the roof, watertight, secure, and clean. Inside the unit, we plan to crimp and connect upgraded 2-aught wire cable directly into the internal wiring of the AC. From there, the wire would run into our new chase down into the RV's underbelly, where it could be neatly secured and protected. The final leg, well, that would be wiring it up into the front bay, where it would land on a 90 amp breaker before connecting to our lithium battery bank. That beautiful plan ran straight into a wall, literally and figuratively.
The wiring demands are way more intense than we expected, and the AC unit wasn't designed to accept our upgraded cable. And suddenly, our clean install turned into a full-on engineering problem. And that's when we realized no one is really talking about this part, maybe for a reason.
Yeah.
So we reached out to the manufacturer, OutEquipPro, to explain our concerns and to see if they had a better suited AC model for our larger sized RV.
When we try to do a proper install, we hit a hard stop. This unit simply isn't built to support the wiring requirements for a full-size RV. In our case, we need about 50 feet of cable each for positive and negative runs. And then we asked, would OutEquipPro be willing to offer a model pre-configured to handle these larger runs with the correct gauge?
They delayed a bit, telling us they were checking with engineering. Then after a follow-up, we finally got a response. They told us extending the 6 AWG cable was the standard solution used by other customers and YouTubers, even though it wasn't technically ideal.
Many of our customers with larger RVs or bus conversions chose to extend the existing wire externally rather than replace the entire wiring, a solution they find both practical and cost effective. That said, we recognize this may not suit every installation scenario, and your feedback underscores the importance of offering more tailored support for users with complex setups.
But this wasn't our concern. Our concern was that we were not comfortable with any of those suggestions.
After consulting with multiple electrical experts, that distance would require one AWG to stay within safe voltage drop levels. The 12-foot of 6 AWG included with the unit is nowhere near enough. And worse, the unit's wiring setup doesn't allow for an easy swap. We'd need to alter the internal wiring block itself to accept a larger cable.
They responded that
while the unit's design doesn't include a built-in distribution block, the main power cable is not hardwired. It is detachable and secured with screws. This allows for replacing the factory cable with appropriately sized wiring if needed. Additionally, the secondary cable connected at the return outlet, which powers the heater, can also be swapped out safely by the user if required.
Overall, they were trying to provide solutions. And from their standpoint, these modifications are
widely recognized in the RV modification community and is common and practical method for handling extended wiring needs. But here's the problem. We'd already been consulting with multiple electricians, running voltage drop calculations, and doing our homework, and we just aren't comfortable with the numbers or their fixes.
All right, so I got curious on how far the 6 AWG they provided could actually be extended and how thick the wire I needed for my conduit to be to safely run it that 50-foot distance. After talking to some electricians and people that do a lot of wiring, they recommended Southwire. The Southwire app is a great resource to figure this information out. So let me show you how you do this. If you just search Southwire, you go to calculator, and we're gonna hop in here and we're gonna play with it. I want to show y'all the process I kind of went through. We're going to click on their voltage drop calculator. So I wanted to clarify some of the information that I was getting because I got mixed information from voltage drops, different wire gauges. So I wanted to come and play with these apps that were recommended. With the Southwire app, it's really easy to use. You're going to click your current, change it to DC. We're going to keep it in feet, single phase, and copper. Copper is going to allow you to run a little bit smaller gauge wire because it's a better conductor than aluminum, but aluminum is cheaper. Let's assume we're using copper wire and we want to go to maximum circuit distance. They're providing us with 6 AWG and we want to know how far we can extend it. Now, in my case, we're using lithium batteries. So let's hop in real quick and do a quick Google search and see what the nominal voltage for lithium batteries are. From a quick Google search, I'm going to use the AI overview. It's 12.6 to 13.6 volts. Let's be conservative. Let's use the 12.6 volts on the nominal side. So we're going to come back to the Southwire app here, and we're going to enter. It won't let you put decimal places, so we're just going to call it 13. It falls in the middle. Now, we need to put in our max voltage drop. This one is a bit controversial. I have a lot of people that have said 10% is fine to use. A lot of electricians said use 3%. So it feels like that's the extreme, most safe, less voltage across your entire drop. So that means whatever voltage you are running, it's going to drop 3% over this distance with this size conductor wire. What I learned was for these AC units, you don't want them to drop below 12 volts. So if we pull up a calculator real quick, so since it's between 12.6 and 13.6 for the nominal voltage, I saw a lot saying 12.8 in other spots. You can see it right here as well. So that's the number I had utilized. 12.8 felt like a safe number for me. Again, this is what I chose. These are the numbers I ran. You have to use your best judgment. This is just what I did. 12.8, and I found that 6% voltage drop keeps it right above that 12 volts that most of these ACs need to continually run. Knowing that information, we're going to utilize 6% for all my calculations. Hopping back in to the Southwire app, we're going to put in 6% voltage drop and current end to end. I'm going to be conservative about it. It can peak around 60, but 55 is probably a safe number. So this here is going to tell us what the safe distance you can extend the 6 AWG that's provided by most of these AC manufacturers. According to the Southwire app, it can be run 16.9 feet. Now remember, you have to take that and divide it by 2. Actually going to be about 8 feet because this total distance is half for your positive and half for your negative. And that gives you your total maximum distance for the circuit based off the 6% voltage drop. Now, I'm sure they were using probably a more conservative voltage drop than this. And that's how they got their numbers with their calculations. Now that we know that, let's see what it would take with the 6% voltage drop that I am comfortable with. I want to know for my distance of 100 feet, because I have 50 foot of positive and 50 foot of negative for a total run length of 100 feet of cable. We're going to utilize the same 13 foot voltage and 6% and 55 at the amperage. Calculating that, it comes to 3/0 AWG. That is some thick wire. I found another app that I want to shout out, FarOutRide. He has a YouTube channel. He's an aerospace engineer by trade, but he has all these really cool tools on his site for van electrical calculators, wire gauge calculators, and PVT calculators, insulation, all these other things. So for this, we want to come to their wire gauge calculator. This one's really simple. So let's see what it gives us. Come here, you can run your 24, 12 volt, weird 12 volt system. We're going to continue with the 55 amps, use our 100 amps. Oops, not 1,000. I'm going to use a 100 amp breaker, and we're going to utilize the 6% voltage drop. That is saying 0 AWG required. That's not too bad. But I noticed this here, loads run continuously for 20 minutes or more. So in my head, the AC unit is probably going to run for more than 20 minutes, especially these 10,000 to 13.5 BTU. They're going to be putting in a lot of work, especially in a rig our size. So when you take that, that makes all the difference. That puts it up to 2/0. That's why when we started planning, we planned for 2/0 cable. And that's really thick wire. It's not cheap. So for our rig, it requires 2/0 to run that 100 foot length. Now, none of these units can be modified to accommodate ring terminals of that size. So that's why we found it to be difficult to recommend that for our viewers for a fifth wheel that size if you're going to have longer run lengths. If you have smaller run lengths, make sure you run your calculations and see what it looks like. I wanted to share these with y'all in case y'all had any questions. If you wanted to run your own calculations and take a look at them, the Southwire app and FarOutRide's app, they are really good tools to utilize.
Any way you look at it, at 60 amps over 50 feet, 6 AWG just simply wasn't going to cut it. You're risking significant voltage drops, poor performance, and possibly damaging your gear, or worse, montage fire. Even after running the numbers, we weren't comfortable with taking apart the AC, swapping out the internal distribution block, running thicker wire inside the unit, adapting the unit for roof thickness, and building a custom air intake separator.
And that's when we hit a wall.
We're not going to share a video that recommends modifying the inside of an AC just to make it compatible with larger RVs.
That's not responsible, and it's definitely not repeatable for the average RVer.
And honestly, even for the most advanced DIYers, that's asking too much of almost anyone.
Yeah, we learned a lot during this.
Yeah. Then we started hearing from other companies. CountryMod reached out to us offering to send their 10,000 BTU AC unit. So we asked, can it handle a 50-foot run? Their response,
our team has tested it yesterday, and this AC cannot be wired to the compressor, so neither the 2/0 terminal nor any other option will work.
We appreciate the honesty, but we're stuck with the same problem. Then Mods Pioneers emailed us. They were excited to collaborate, said their unit was super efficient, whisper quiet, and came with 14.7 feet of 6 AWG wire. And so we asked the usual, Can it be wired over 50 feet with 2-aught or 1 AWG cable? And their response was more flexible.
To ensure optimal operation over a 50-foot distance, we recommend upgrading to 1 AWG, preferable, or 2 AWG copper wiring for both positive and negative lines.
Still, no large terminals at the compressor or long-run solutions.
This will help maintain voltage levels and prevent potential issues. Additionally, it's crucial to test the system under full load to confirm the voltage at the unit remains stable, ideally above 11 volt to ensure efficient cooling performance.
It was becoming crystal clear. Most of these 12-volt ACs are not meant for rigs of our size. Most of these 12-volt ACs are marketed for RVs, and what they really mean are stands, short trailers, and rigs with batteries near the AC. If you're in a 35 to 40-foot RV with batteries in the front bay,
Yeah, you're gonna run into major challenges. Hang tight though, because we are still in the market for a solution that works for our rig.
if you've installed a 12-volt AC in any rig, van, schoolie, camper van, semi-head, we want to hear about it. Drop your brand. We want to know how long is your rig and does it cool well?
Yeah, and fifth wheels too. She left them out, but y'all are included.
Obviously.
Thanks for watching. If you found this helpful, make sure you hit that like button, subscribe.
And comment because it keeps our channel growing. Thank you.
We'll see y'all next time.